Hey, welcome to homework 1.6 exercises. This is still on midpoints and distances in the coordinate plane. Your full problem set of exercises is there, page 47, 1 through 9, 13, 15, 21, and 37, all odd. I'm going to be working through just the first several of the first problems, 3, 5, and then 7 in this exercise video. All right, so let's go ahead and jump right into question number 3. Question number 3 says that CD, segment CD with endpoints 0, 8, -8, and D, 3, 0, find the directions, they find the midpoint, okay? So I want to find the middle of this segment. You don't always have to sketch these out like I've done here, but I'm going to be doing that to clearly demonstrate what we're talking about. When you get good at this, by all means, you don't have to graph these. But if we remember, just to review how to find the midpoint, you're going to take the two x points and find their midpoint by adding them and dividing by 2. And then you're going to take the two y points, add them together, and find their midpoint by dividing by 2. Okay, so my two x points here are 0 and 3. And again, you can start to do this very fast mentally. I'm going to move more slowly. But that means we're going to go 0 plus 3 divided by 2. So that's simply 3 divided by 2, which is 1 1/2. Okay, our two y points are -8 and 0. So we've got -8 plus 0 divided by 2. That's going to be -8 divided by 2, so that's -4. So I should find the middle of this segment at 1 1/2, -4. Well, let's check it out. I'll switch colors here so we can see it. So if I go over 1 1/2, 1 and then 1/2, down 4, 1, 2, 3, 4. There she is. And that looks to be about right. So even my answer looks good. I don't have to graph this, but it's nice to know sometimes in math if you're on the right track, and you can usually check that. But yes, that is our midpoint, 1 1/2, comma, -4. So it's that simple. And again, I didn't have to graph it to do that, but it's a nice little check to see if everything's matching up properly. Okay, so question 5 is still a midpoint problem, but it's a variation. And so I wanted to demonstrate it because you got to be careful because it's slightly more complicated than the one we just did. And that's because number 5 says B is the midpoint of segment AC. A has coordinates -3, 4, and B has coordinates -1 1/2, 1. Find the coordinates of C. So you don't want to quickly just add the two x's and add the two y's and divide both by 2, because then what you would be doing, and I've graphed A and B here, A is up on top and B is down low, is if you just did that, you would be finding midpoint right about here. Okay, which we could do, but that's not what the question's asking. If you read carefully, the question is actually that B, this point here, or that point there, that actually is the midpoint. So the problem is actually saying, where's the other end point? If this is A up at the top, B's in the middle, so that means there must be a C somewhere down here that is the other end point. And so how can we find that? Okay, and there's a couple different ways to do it, but I'm just going to show you how I personally would recommend it. And then, of course, whatever makes sense to you, you can solve it that way. Okay, what I recommend is looking at the x change and the y change, the vertical change and the horizontal change, because from the end point to the midpoint down to the last end point, that would be the same. So for example, let's look at the vertical change. From this top point, going from 4 to 1, how much did it change? It went down 1, 2, 3. So it dropped 3 to the midpoint. That means the end point must be another vertical change of 3. And so from this point, if I go down 1, 2, 3, I know that it must be down here at -2. This is over at -2 on the y-axis. Okay, so that's I must have a horizontal change of 3 taking us down to -2. Now, what's the horizontal change? Well, in going from -3 to -1 1/2, that was a change of 1 1/2. Okay, because that's if I subtract, you could just subtract these numbers. -3 minus 1 1/2 will give you 1 1/2. So that means I need to go over 1.5, and that'll be where the other endpoint must be. So if I go over 1.5, there I am, boom, at 0. So I know that my x-coordinate must be at 0. So a vertical change will put me down 3, which then takes me to -2. A horizontal change will take me 1.5, which puts me at 0. And if I plot that point, I've kind of scribbled a lot of things here. Whoops. We can see that over 0 down 2 does pretty much perfectly finish my line. And so that means C is down here at 0, -2. Okay? And so there is my endpoint. So slightly different than the number 3 because they're giving you the endpoint and you actually have to deduce what the other endpoint is. So I personally like to do it this way. I'm going to show you one other way as an example. But, whoops, woo, we're flying. Okay, meant to erase that. But I recommend just looking at it and saying, okay, what was the horizontal change? And then copying that from the midpoint. What was the vertical change? And copying that from the endpoint. So, so I basically went over 1.5. Whoops. I went over 1.5, and then we went down 3, because that's what happened here. This was over 1.5 and down. Whoa, that's cool. No, this was over 1.5 and down 3 to begin with. And we just copied that. Here's the other way, kind of the more arithmetic or algebraic way to do it. I'm going to go ahead and show you that in case what I just showed you not your cup of tea. And that is we have our formula. We have our x plus x divided by 2 and our y plus y divided by 2. And each of these equal kind of the midpoint coordinate, right? So what we can do is we can use that formula, but we plug things in a little more differently. In other words, I know what my first x point is -3, but I don't know my other one. So I put that in as my variable divided by 2. But now I know what the midpoint is. I know that the midpoint for x is -1.5. Okay, so now if you look at this, I now have an equation that I can solve. I can say -3 plus the unknown x value divided by 2 gave me the midpoint of -1.5. Well, let's undo that. Instead of dividing by 2, I'm going to multiply both sides by 2. Okay, so that cancels out, and I get 2 times -1.5 is going to give me -3. So I get -3 equals -3 plus x. Then I'm going to get x by itself by adding 3 to both sides. That cancels out. In fact, that cancels out too. So I'm left with an answer of x equals 0. So my x coordinate is 0. Well, that's what we found. So boom, there's another way to get that answer. Then we would repeat that with the y. We would say, well, I know one y coordinate, that is 4. So 4 plus the other y I don't know divided by 2 equals the midpoint of y we were given is 1. So there it is. I've written the equation. Notice the difference is I know the answer. I know the midpoint. I don't know the other endpoint. And now we just solve that algebraically too. Instead of dividing by 2, we're going to multiply by 2. Cancels out. And so now we have 4 plus y equals 1 times 2 is 2. I can subtract my 2. I'm sorry, I'm going to subtract 4 to get y by itself. That cancels out. And now I have it. I have my y is equal to 2 minus 4 is going to be -2. So my y coordinate is -2. And we can see that that is also what we already knew. So there you go. You have two methods for finding, and these problems will come up. And that's why I'm bothering to assign it and demonstrate it, is if they give you the midpoint and one of the endpoints, and you're trying to find the second endpoint, you have two ways of doing it. You can count it out on the graph like I have, and whatever the change is horizontally and vertically, just do that again from the midpoint, or just plug everything into the formula. Only realize you only have one of the x's or one of the y's, but you now have the midpoint and you're just going to solve backwards. You're going to algebraically solve for the missing x or the missing y. Okay, whatever floats your boat. Good luck. Okay, and the last one, number 7, is a distance, is just practicing the distance between 2 points. The problem reads, find the length of the given segments and determine if they are congruent. Okay, so we're going to, the two that in number 7 are segment JK and segment RS, and we're trying to figure out, are they congruent? Okay, and the whole point is just to practice our distance formula. How far apart is it from J to K? How far is that the same as or different from the distance from R to S? So we're basically going to get to practice twice finding the distance. So let's do that. The distance start with J to K. If I look at this point, well, again, I'll start from how I demonstrated in the homework. Let's make a right triangle. We want to make a right triangle that tracks the horizontal difference between the two numbers, the two endpoints, and the vertical distance. And you can see immediately I have a right triangle. And so if we're going to use the Pythagorean theorem, a squared plus b squared equals c squared, let's just find, well, what are A and B? What are the horizontal and vertical legs of this triangle? Well, that's pretty easy. I can just even, I was about to actually figure out what the coordinates are. I don't need to do that. I'm just going to count. I'm just going to go 1, 2, 3, 4, 5. So this horizontal difference is 5. Vertically, 1, 2. That distance is 2. Very easy. Now I can simply plug those numbers in. 5 squared plus 2 squared equals my c squared. All right, well, that's 25 plus 4 equals c squared, which is now 29 equals c squared. And remember, my answer is not 29, but the opposite of squaring a number is square rooting. So I'm going to square root both sides. It takes away my square. And so I can see c is equal to either the square root of 29, or if I plug that into my calculator, I think that is approximately 5.3. So JK, this is JK, is approximately 5.3. So now let's compare that to RS. And of course, you could probably try to eyeball this and just give which one's longer, but that's not the point. You need to practice the solving of the distance in order to compare them. So don't just say on this problem which one's longer. It's pretty clear, I think, that RS is longer, but you want to actually have the two measurements to relate to each other. So let's repeat the exact same process, but let's do it with RS. Again, find the horizontal and the vertical change. Make our little right triangle out of it. So here's our vertical change. Whoops, I went too far. Our vertical change is here. Our horizontal change is here. Count that out, 1, 2, 3. So it's 3 units high, and it's 1, 2, 3, 4, 5, 6. 6 units long. So immediately we can see it's going to be bigger than JK. But let's actually see what it is. So let's go 3 squared plus 6 squared equals c squared. All right, that's 9 plus 36 equals c squared. So 45 equals c squared. And then we need to take the square root of both sides, and we can see that c is approximately equal to, this one I don't know, let me calculate that real quick. Do not have a problem with you using a calculator at this point. Square root of 45 is approximately 6.7. Okay, and that is equal to RS. So we can see 5.3, the other one is longer, 6.7. And so the answer to the basic question, are they congruent? No, they are not congruent. And actually, it does say find the length of the given segment. So you can't just say yes or no. But we do want to say no, they are not congruent. But all that, the main idea there is to practice twice finding the distance between 2 points. And again, to summarize, it basically creates a right triangle, which you can very quickly find the vertical and horizontal distances and use those two in the Pythagorean theorem to find your hypotenuse, because that distance between those 2 points is just basically a hypotenuse. Alrighty, well, good luck with the rest of the problems. Please reach out if you have any questions. I'm very eager to help and definitely don't want you to feel frustrated or confused as you try to figure this out. So reach out to me and we'll be having class on Thursday. All right, see you soon.